All right, so now we're going to take a peek at section 2.3, still looking at polynomials and behavior and graphs and zeros and all of that. And we're going to look at other ways to find zeros. When factoring isn't always super easy, or maybe we can find one factor, we want to find the rest, and we're going to use something called synthetic division to be able to do that. But before we can get to synthetic division, which I know you've talked about in Algebra 2, we're going to talk about long division. So what it means to divide polynomials by other polynomials. So we're working on doing operations with polynomials. And we're going to use synthetic then to also divide by binomials of the form x minus k. So like our regular factors that we would see when we talk about polynomials. So that's kind of our part one. So our essential questions are, how can I use long division to divide polynomials? And then how can I use synthetic division to divide polynomials? So before we can do that, we need to do some division. We need to talk about what it means to do this divide. So I'm going to have you go old school here, no calculators. We're going to do some division. So first I'm going to do is 259 divided by 7. So first order of business is to figure out, okay, what goes underneath and then what's on the outside. So 259 underneath and the 7 on the outside. So when we talk about it, the number that's underneath, that's the our dividend, and then the 7 is the divisor, so what we get. So when we do this division, then we get the answer, which is called the quotient. So we'll talk lots more about those words. All right, so how do we do this division? So we're going to see how many times does 7 divide into. We're going to look at the first digit first, the 2. Well, it doesn't divide into 2, but does it divide into 25? Sure does. And how many times? 3 times. What do you do with the 3 and the 7? You multiply, so 21, and then what do we do with those two numbers? You subtract. So 25 minus 21 is a 4. So that multiply and then subtract is really important. We need to think about that when we do a regular long division. Then what do we do next? We bring down the 9 and we start over. So how many times does 7 divide into 49? 7 times. So 7 times 7 is 49. And we get a lovely remainder of 0. Okay, so a remainder of 0 means this 7 divided into 259 evenly. So we're going to be talking about some of these terminology things that we can say for all of these. So the 259, what that means is then basically it's 7 times 37. That's how that works, that opposite operation. Or if we say what's 259 divided by 7? Well, we got 37, so those are kind of two different ways to think about it. So this one divided evenly, there was no remainder. But that isn't always the case, so let's take a look at another one. So we're going to take 59 divided by 4. So 4 is the divisor here. 59 is what we call the dividend, what's being divided. All right, so 4 divides into 5 once. We do 1 times 4, we get a 4, and we subtract. So multiply then subtract, we get a 1, bring down the 9. 4 divides into 19. How many times completely? Well, 4 complete times. 4 times 4 would be 16. Subtract with 3 left over. Uh-oh. A remainder. All right, so there's tons of different ways that we've written remainders and dealt with this 3. If you want to keep going with the decimal answer, I know we would have added a decimal point, brought down a 0. Don't want to do that because we can't really do that when we're dividing with polynomials. There aren't any decimals in there. So how can we write the remainder? Well, I know back in elementary school, you'd probably do R3. Remember that, the good old days. But what does that mean? What's actually left over? Well, 3 out of 4 is left over. So let's think about how we could write this. If I take 59 divided by 4, I get 14 whole plus 3/4 left over. I know we would probably just write that 14 and 3/4, but that's what it is. In this case, I had no remainder, so it would have been a plus 0. I didn't have to worry about it. Or I could say 59 is equal to 4 times 14 plus a remainder of 3. So it's 4 times 14. So we have 14 4s plus 3 out of 4 left over. So this process that we talk about for division is the same when we look at long division with polynomials. So the actual division algorithm, there's 2 different ways to write it, and I'm going to show you both. So this is exactly what we just did. The dividend, which is what goes underneath, what you have under the dividing symbol, is equal to your divisor, what you're dividing by, times the quotient, plus whatever remainder you have left over. Another way to think of that is the function dividend divided by the divisor is equal to what? Well, it's the quotient, your answer, plus the remainder over that divisor as well. What part do you have left over? So we're going to follow that same format that you do for regular numbers when we divide our polynomials. So really, the why. Why do we need to divide polynomials? So, well, we're trying to find zeros. We're trying to be able to factor it to see if something divides in there evenly, no remainder, and be able to solve. So we're trying to find polynomials to find their, and use finding to find their zeros. So looking for zeros is our quest when we're dividing. So when dividing a polynomial by another polynomial, so when they say f of x, that's like your dividend, right? What you're dividing, the thing that's underneath the divide symbol, and the d of x, they're calling that's the divisor, what you're dividing by. So f of x divided by d of x. If the remainder is 0, what that means is that d of x, the divisor, divides evenly, right, into that function. And why do we care about divides evenly? That means it's a factor. Right, and that's the important part, the being able to find a factor, then you can find the 0. So if it's a factor, then you know it's a 0. So that's kind of our quest. We're going to be dividing polynomials, and you can divide any polynomial by any other polynomial, a degree 7 by a degree whatever. The higher the degree, though, the harder that is, the more work it is to be able to do that. So when you're going to divide these polynomials, there's a few things to keep in mind. Make sure you write your terms in descending order, so highest degree term down to lowest degree. If you're missing a term, you've got to make sure you insert the placeholder with 0 coefficients. So for example, if I didn't have an x squared term, I would still want to put in the 0x squared to be able to make sure I have that place value represented. It's the same thing when we do regular division. You don't even think about it though. So if I ask you to divide 405 by, say, I don't know, 13. You would never, when you're doing the division, just say, oh, well, I don't have any 10s, so I'm just going to put 45. You wouldn't get the same answer. You need to have 405 underneath. You need the placeholder for the 10s spot. This is absolutely the same thing. So if you don't have a power represented, we need to put in a 0 for that. All right, so let's take a peek and see if we can try to do this division and see if this works. So we're going to take a degree 3 and we're going to divide it by a degree 2. So this is your dividend and this is your divisor. And what we're going to be looking for is our answer, which is the quotient. So we're saying, hey, we're going to do 3x cubed plus 4x minus 2. We're dividing it by x squared plus 2x plus 1, and I want to see what my quotient is. I want to get that answer. All right, so underneath, we're going to put our dividend. So we've got 3x cubed highest degree. Do you have an x squared? No. So I need to put in a placeholder. So 0x squared plus 4x and then minus 2. My divisor goes on the outside. If you need placeholders there, we still need to put them even in the divisor. But the divisor looks good. We don't have any holes there. All right, so how do we do long division with polynomials? So we use our highest degree terms. So we're going to see what do I need to multiply x squared by to make a 3x cubed. So think about what you would need to make that happen. What would you multiply x squared by to get 3x cubed? Well, you need one more power of x and you need a 3. So it looks like 3x would do it. So I'm going to multiply by 3x. Here's another way to figure that out though. Just do the division. Take 3x cubed divided by x squared and reduce that, and you're going to get exactly what you need to multiply by. So we need to multiply by a 3x. Sometimes that's easier for people just to divide. Now it's an x, right? That's linear, degree 1. So where you put it then, we got to keep our place values accurate here. We put it above the same degree term in that dividend. So just be careful there, that'll really help. So that's what I'm going to multiply by. Now I'm going to multiply this 3x term by this entire polynomial. So I'm going to multiply the 3x times the x squared, the 2x, and the 1. Now I'm going to show my scratch work here. I'm going to line it up right underneath though. So I'm just going to do this. That's the work I'm doing. So 3x cubed plus 6x squared plus 3x. Okay, so I'm just multiplying the 3x, just like you did in our regular long division. All right, so here's where this goes, though. I'm going to go ahead and put that underneath. So it goes right here, 3x cubed plus 2x squared, or pardon me, 6x squared. and then plus 3x. Now notice how everything has something to line up with for place value, even the x squared, and that's where people get into trouble. So be careful, make sure you have those placeholders. Okay, what do you do next in long division? You subtract. Now something to notice, the first terms should always be identical. That's how you made them. That first term should always be a 0. So I don't usually write 0x cubed because that's what should always happen. You certainly could if you wanted to. Sometimes the less writing is a little bit better. Be careful, we're subtracting everything here. 0 minus 6 is going to be a negative 6x squared. Remember, we're just doing like terms here. And then 4x minus 3x is going to be a 1x. Okay, what do you do in regular long division after you subtract? You bring down the next number, which is our minus 2 or our constant. And then you start over. We do the same thing. All right, so here's what you need to think then. We're looking at our highest degree terms, the x squared and the negative 6x squared. So what would you multiply by this x squared term to get a negative 6x squared? Well, sure looks like you just need a negative 6, right? Or remember the other way to think of it, just divide. Negative 6x squared divided by x squared and just reduce that fraction. Sometimes that's easier for people just to figure out that negative 6. So what I need to multiply by is a negative 6. Notice negative 6 is a constant, so it should go above the constant in your dividend. All right, so we're going to multiply everything in this divisor by negative 6. So the scratch work here, if this helps you, just do the scratch work kind of off to the side, but you're distributing there, and that's what we're going to line up. So we got a negative 6x squared, a minus 12x, and a minus 6. So that's kind of my scratch work. So I am multiplying negative 6 times my divisor, and I get negative 6x squared minus 12x minus 6, and I'm going to subtract. All right, now here's the tricky part again for a lot of people. This subtracting out here is just a disaster. Remember, you're subtracting all of those. So use parentheses, think about whatever you need to do here. When I subtract the first ones, remember this should always be a 0. So negative 6 of them minus a negative plus positive, that would definitely be a 0x squared again. But again, most people don't write it, but you could if you wanted. Okay, next one. 1 minus a negative 12. 1 minus a negative 12 plus positive, that would be 13x. All right, negative 2 minus a negative 6. So negative 2 minus a negative 6 plus positive, that would be a positive 4. So I have a remainder. Okay, so there's my remainder. What's my quotient? This is my quotient. That's my answer. That's the number of complete x squared plus 2x plus 1s I can get into that polynomial, but it didn't divide evenly. I had a remainder. Okay, so how would you write your answer then? So remember our format here that we were talking about. So we're going to do kind of this bottom one, the quotient plus the remainder. So we're going to write it that bottom way. So let's do that. So when I take 3x squared plus 4x minus 2 and divide it by x squared plus 2x plus 1, I get 3x minus 6, that quotient, plus my remainder. My remainder was 13x plus 4 over that whole thing. X squared plus 2x plus 1. It's the same kind of format that we were talking about for the regular long division. And this makes the most sense for us for how we're going to write them for polynomials. So the quotient, and then this is the remainder over the divisor. All right, so long division can be a little tricky, especially the bigger the powers you get, but we can do it. It works. And there's times where we have to. We can't use any shortcuts, but sometimes we can shortcut. So let's talk about the shortcut. You can use something called synthetic. I always thought this was kind of an interesting term, but synthetic is kind of like man-made. It's kind of the fake version, like if you have cotton, then you have synthetic fabrics. So cotton found in the real world, right? Or made from real world things. Synthetic is something that's kind of man-made. So the synthetic is kind of the take out the stuff and make it a little bit easier. So can synthetic division be used to divide a polynomial by this divisor? No, because it's degree 2. Because that divisor is degree 2, you cannot use synthetic division. You can only use synthetic division when it's dividing by a degree 1 factor. Okay, so could you divide by x plus 4? Yes, you absolutely could, because that's a degree 1. So you can only use synthetic division when you're dividing by a degree 1 factor. That's the only time you can use it. All right, so let's take a peek and see, and then we're going to practice it as well. So divide this polynomial, a degree 3, divided by this, and use the result to factor the polynomial completely. So first of all, can we use synthetic division to be able to do this? Well, yes, because this is degree 1. So we could do long division if we wanted to, and we absolutely could. I'm going to try synthetic for this one and long, just so we can kind of compare and see what makes sense. So we'll see what that looks like, and then we'll talk about how would we get the other factors from what's left over then. So we're going to start with kind of this long division approach just to practice one more. So there's our dividend and our divisor. Okay, so we can kind of see the numbers as we go along, and then we'll practice that long division. So we start with our highest degree one. So what do I multiply x by to get 9x cubed? Well, I need a 9x squared. So this would be a 9x squared. Notice above the same place value, and I multiply. So that would be 9x cubed plus 36x squared. Okay, so watch what happens when we do this, when we subtract. Everything here is 0. There's no x cubes, there's no x squared, nothing. All you have left then is a bring down. This is a minus 49x, and I'm going to keep my 0x squared. So I'm going to keep that second one, so because I'm dividing by a binomial, I should have a binomial here. I wanted you to see what happens here, though, because it's a little bit goofy. That kind of stresses people out. What would you multiply an x by to get a 0x squared? Well, a 0. I know that seems odd, but sometimes you're going to have placeholders in your quotients as well. So that would be a 0x. So when I multiply by 0x, I would get 0 for everything. And I subtract. That would leave me with a minus 49x, and I'm going to bring down the 196. And I start over last time. So x times what would give you negative 49? X would be minus 49. So multiply negative 49x and then minus, I think that's 196, so I get a remainder of 0. So that would be the kind of long division approach to be able to do this. The quotient should be, if I take 9x cubed plus 36x squared minus 49x minus 196 divided by x plus 4, my quotient or my answer should be 9x squared minus 49. Okay, so that's kind of the long division approach. Let's take a peek at synthetic. How does synthetic, make this a little bit easier? I'm going to put that back up there. So let's try synthetic division. What synthetic division is it takes out all of the variable terms and you only use the coefficients. So we're going to focus our attention in on the coefficients. You still need placeholders though if you're missing something, so don't forget about that. But we're going to write out our coefficients. So there are my coefficients for my dividend. And now let's be careful on the divisor. If your factor is x plus 4, think about setting that equal to 0 and solving it. What is your actual x value then? It's a negative 4. So what we're actually dividing by here is a negative 4. So let's be careful on our k value. Now this is how I've always set up synthetic division. People have different ways of doing that, but what I'm dividing by I kind of put over here on the side, and then my coefficients. And then see if you can remember how synthetic division works. First thing you do is you bring down that first coefficient. This is kind of the shortcut for long division. Can only use it though when it's a linear factor. And we multiply still. So we multiply negative 4 times negative or times positive 9. We get a negative 36. It goes right under the next place value down. Now here's the thing, you're going to add here. We're adding because we've already factored in the sign in the k value that we're dividing by. So make sure you're adding here. So 36 plus negative 36 is 0. That's good because if we look back at our long division, remember we had that 0x, so that makes sense when I take a peek at that. All right, next thing, we start over again. So negative 4 times 0, well, that's 0. Add again, remember, so we're adding here. Negative 49 plus 0, negative 49. Well, that seems pretty good because if I look back at my long division, I had a minus 49 there, so that makes me feel good. And then I finish up here, multiply again, negative 4 times negative 49, positive 196, add, we get 0. So my remainder is 0. What does that tell me? It means that this factor divided what we call evenly, right? And it did in long division as well. Divided evenly, meaning this is a factor. So x plus 4 is a factor of this polynomial. So when I divided by x plus 4, I got a whole number answer. We're going to talk about that and what that means here in just a second. Let's look at from synthetic though. How would you tell that the answer is actually 9x squared minus 49? We're going to work our way backwards. So this was the remainder, it was 0. That's how we knew it was evenly. This is going to be your constant. We're just going to work our way backwards. This would be your degree 1 term, and this would be your degree 2 term. So working our way back. So that means I can put the variables back in then that this is 9x squared, no x's, and 49 is our constant. Now you don't need to put the plus 0x unless that helps you keep track of what you're doing. So we work our way back up. We get the exact same answer as what we had from before. Okay, so what does that mean then? Well, that means if I take this x plus 4 times the 9x squared minus 49, remember our other way to write it, that's going to give me that original function that I started with. So that was kind of our other representation of division when we talked about those beginning ones. This dividend is equal to the divisor times the quotient. And this is how we're going to work forward then to be able to see what all the zeros are. I know that x plus 4 is a factor now because it divided evenly. I could either use long or synthetic to do that, but now I could keep going and factor this other polynomial further, and I can see what the other factors of this polynomial would be. So let's see if I can find the other factors. 9x squared, how do you multiply to get 9x squared? Well, that would be 3x and 3x. These are both perfect squares, so this should work well. If it's a negative, that means plus and minus. And then how do you get 49? 7 and 7. So when I think about it, this would be the same polynomial over here. It's 3 factors, 3x plus 7, 3x minus 7, and x plus 4. I was actually able to find all the factors, right? Because I was able to find out that one of them was a factor. So using division to get this 0 remainder helped me figure out what all of my other factors were. So these are what are called the factors of the polynomial. If I multiply them together, I get back to this polynomial I started with. Can you find the zeros then? I know I didn't ask you, but could you find the zeros then? Yes, you set each of these equal to 0 and you solve. So just make sure you know the difference between what a factor is, what you multiply together, versus what the zeros are. The zeros for this one, where does it cross the x-axis, would be at -4, -3/7, and positive, oh, sorry, 7/3, help me, 7/3, and then positive 7/3. So zeros are the actual locations, the x-intercepts. The factors are those linear binomials that you multiply together to get that. So synthetic division can be a great tool to help get us to those factors a little bit faster. So let's figure out this last one, and then I think we should be in good shape on synthetic division and finding factors. So we're going to take a degree 4 divided by a degree 1. So first of all, can we use synthetic division for this? Yes, because it's degree 1, so we know we're going to do that. Let's just think common sense. A degree 4 divided by a degree 1 should be a degree 3 answer then, right? So that might help you also to be able to do this. Now, your textbook uses a little bit different setup to do this long division, but we still do the same idea for putting in zeros for placeholders. So they use a big box like this. You can decide I'll kind of do this one this way. So descending order, so double check, and we're going to put in placeholders. So I have a 2 for x to the 4th. Do you have x to the 3rd? Nope, so I'm going to need a 0. Then I have x squared, which is 5. Do I have an x? No, so I need another placeholder. And then I have my constant, which is -3. Now, x plus minus 5 means the 0 that we're talking about here is x equals 5. So positive 5 is what I'm dividing by. So this is another way to draw the line if this helps you keep your information organized. First thing we do in synthetic, we bring down our first digit, which is the 2, and we multiply, which would be 10, and then we add. So that would be 10. Multiply again, that would be 50, which is going to give me 55. Multiply 5 times 55, we get 275, which would be 275. And multiply again, which is 1375, I believe, and add, which would be 1372. So this is the remainder. So this did not divide evenly. So if we were trying to use this to check to see, is x minus 5 a factor? So is this Binomial a factor? I would say definitely no, because we did not get a zero remainder. It wouldn't be a way to be able to tell that. So how would you write your quotient here? So when I took 2x to the fourth plus 5x squared minus 3 and divided by x minus 5, what did we get? All right, so let's work our way backwards. This was the remainder. That means this would be the constant. This would be degree 1, degree 2, and degree 3. Now remember common sense. A degree 4 divided by a degree 1 makes sense. It should be a degree 3, right? So double check that when you write out your answer. So 2x to the third plus 10x to the second plus 55x plus 275 plus my remainder, 1372 over, and then what was our divisor? X minus 5. So just like we would do a regular remainder for our values. So synthetic division can be a great tool, but remember, you can only use it again when you're dividing by degree 1. All right, so what we talked about, let's go back to our essential question. How can I use long division to divide polynomials by other polynomials? Those can be any degree polynomials. Use your zero placeholders. It works just like regular division. Using synthetic is great for finding zeros, but remember, only by binomials that are linear.